What's up, guys? Today's lesson is on another commonly referred example of a living fossil, the Atlantic horseshoe crab. The first example of a living fossil I talked about was the coelacanth, which I've made a video on right here. But don't go yet, because this video is super interesting. Trust me, I made it, and I think it is. The Atlantic horseshoe crab's scientific name is Limulus polyphemus. Limulus meaning oblique or askew, and polyphemus referring to the one-eyed giant Polyphemus in Greek mythology. It was named after the giant because of a misconception that the animal had a single giant eye, but in reality, it has a lot more than just one. No clue where they got that idea from. What were they, stupid? As for its common name, a part of it is very misleading, since the Atlantic horseshoe crab actually isn't really a crab. It's more closely related to scorpions and spiders than it is to true crabs and shrimp, so maybe it should be called the Atlantic horseshoe spider, but the Atlantic horseshoe would be as simple as it gets. If you've watched my coelacanth video, you might remember what a living fossil refers to. But for those new to the channel and don't know, the Atlantic horseshoe crab is called a living fossil because its basic body structure pretty much hasn't changed for over 420 million years. 420, haha. Between males and females, they basically look the exact same in appearance, but it's in their size where they differ. Females tend to be around 25% bigger than males, being able to reach up to 2 feet in length, yes, that includes the tail, and weigh up to 11 pounds. As the Atlantic horseshoe crabs grow bigger and bigger, they have to shed their exoskeletons, or their shells, which are now too small to hold their bodies. You can actually keep a horseshoe crab shell if you find one by the beach, but you can't kill a live horseshoe crab just to get one, because that's illegal. Looking at its anatomy, the Atlantic horseshoe crab's body is made of 3 parts: the prosoma, its head, the epistosoma, its central area, and the telson, its tail. Its prosoma is the reason why it has horseshoe in its common name, because the smoothly curved head resembles the shape of a horseshoe. I personally think it resembles the shape of a horseshoe crab, but that might be a hot take. Now for its tail, try not to let it scare you. It's really not that bad. It doesn't have any venom or anything scary like that. In fact, its main purpose is to act as a rudder to steer through water and to flip itself back over when a wave turns them upside down. Looks kind of like this. Now, even though they can do this, their tails aren't really that effective at flipping themselves, so it's actually recommended for beachgoers to flip them over if they're stuck on their backs. So be a pal and give it a hand. Though be sure to pick them up by their sides, not from its tail. The Atlantic horseshoe crab has 10 eyes scattered throughout its body, making it nowhere similar to Polyphemus its species name was named after. Some of its eyes are different from others, ranging from compound eyes to light-sensitive photoreceptors, letting them find mates and navigate the ocean floor by detecting light and movement. Their colors range from a dull olive green to black and to brown, though that's only on the surface. Their underside is a lot more brown in color. Observing its underside, beneath the Atlantic horseshoe crab's head are 6 pairs of appendages which have different functions. The first pair at the front of its head is used to pass food into its mouth, the second pair called pedipalps that act as sensory organs and walking legs, and the rest are used for movement. Fun fact: the pedipalps of males are tipped with claspers, which they use during mating to hold onto the female's head. I hope they ask for consent first. Remember folks, no means no. Next, the Atlantic horseshoe crab's central abdominal area has 6 more pairs of appendages, though if you couldn't tell, they look pretty different from the first 6. The first pair has its genital pores, while the rest are modified plates called book gills, which let it breathe underwater and even breathe on land for a short amount of time, though only if the gills are kept moist. Oh, did me saying that word bother you? Well, I'm gonna say it again. Moist. Let's be real, guys. It's not even that gross of a word. You're just saying it is because everyone else says it is. It's not that bad. And now for our final cool fact about the Atlantic horseshoe crab's physical characteristics, they have some cool blood. Their unique blood is called blue blood because of how it turns blue due to its copper-based protein when exposed to oxygen, called hemocyanin. What's also pretty sick is that their blood has a type of blood cell called amoebocytes, which detect the presence of disease-causing bacteria and result in the blood coagulating. And if you think gas prices are high, look at horseshoe crab blood. That might be a bad comparison, but it's my channel, you can't stop me. The Atlantic horseshoe crab's special blood goes for a whopping $60,000 per gallon, making it extremely valuable and resulting in about 15 to 20% of them dying due to extraction of their blood, often for scientific purposes. God, I hate people sometimes, man. These guys already have it rough when they're on their backs. They don't need their blood drained too. The Atlantic horseshoe crab is the only living species of horseshoe crab native to the Americas. All the other species live around Asia. Just based on their common name, you can infer that this horseshoe crab is mostly found along the Atlantic coast of North America and Central America. But in Central America, its distribution only reaches to Mexico's Yucatan Peninsula, so it's mostly found around North America's Atlantic coast. Where they are in these areas depends on the season. During the spring and summer, adults can be found in shallower waters like sand or mudflats, estuaries, and mangrove swamps. But during the colder months like in the fall or winter, they'll migrate to deeper waters up to 200 meters deep like around the Atlantic continental shelf. An adult Atlantic horseshoe crab mostly eats small mollusks like clams, but will also eat marine worms, crustaceans, and bits of dead fish. However, it doesn't have teeth, so the Atlantic horseshoe crab uses the spine on its legs to crush its food before being passed to the very front legs once broken down enough, which move the food to its mouth. A pretty inconvenient way of feeding, but it works. As for young juvenile Atlantic horseshoe crabs, they'll eat smaller organic particles for some time until they grow older, finally being able to eat meals fit for a king. Small clams and worms? That sounds delicious. I mentioned earlier that Atlantic horseshoe crabs will move to shallower waters during the spring and summer, and the reason why they do is because this specific time period is the spawning period. And during an even more specific set of conditions, the crabs will arrive onto beaches in large numbers, the conditions being during high tides of full and new moons when water rises the highest at the beach. When a female is ready to lay her eggs, she will crawl to the beach with a male already attached to the top of her with his claspers. During the spawning process, the female will drag the male around with her as she lays eggs, which are green. No, I'm good, thank you. However, oftentimes other males can also try to fertilize the female's eggs themselves by positioning themselves on and around the couple as the female lays her eggs. That's a scenario I refuse to imagine for us. Every few feet on the beach, the female will dig a nest in which she'll lay as many as 3,600 eggs, doing this for up to 4 or 5 nests per day for up to several days, potentially laying 100,000 eggs or more. After fertilization, whether by the attached male or by some other male, the female will cover the eggs with sand, and eventually, the eggs will hatch around 2 to 4 weeks later, resulting in tailless, green, free-swimming larvae that will be swept away into the ocean by the high tide and settle to the ground after around 6 days. Once hatched, the baby Atlantic horseshoe crab will begin its first molt about 20 days after hatching. With every molt, the horseshoe crab will grow about 25% in length until they reach adulthood. For males, it'll take around 16 molts before they become adults, and for females, it'll take around 17. God, I hope that was a big enough gap between the numbers to avoid that. Occasionally though, horseshoe crabs can have one more molt during its lifespan as an adult. For its lifespan, we don't have an exact age they can live to, but the average is thought to range from 20 to 40 years. Quite a big estimated range, don't you think? According to the IUCN Red List, the Atlantic horseshoe crab is classified as a vulnerable species, last assessed in 2016. Their populations have continued to decrease today and because of a number of reasons. First off, they have many predators, including sharks, sea turtles, and birds which can eat both adult and young Atlantic horseshoe crabs. However, the most serious predator of these crabs are humans, who often capture them to use as bait for eel, whelk, and conch trapping, as well as for fertilizers and scientific purposes. Because of this, there have been state and federal regulations on the harvesting of Atlantic horseshoe crabs, prohibiting people from using them as eel bait or for fertilizers. In addition, climate change can negatively affect their spawning areas due to rising sea levels and the ocean acidification affecting their shell development. Atlantic horseshoe crabs have adapted to environmental changes throughout the millions of years they've been alive for, but for these changes to occur as fast as they are now, I highly doubt they can continue doing so. Soon enough, they'll go from living fossils to just fossils, and that's a lot more boring of a label. But anyway, that's about it for today's lesson. Subscribe for more fish facts, and I'll see you next time.